Hello there. In this video, I will show you how to um, use the normal distribution to solve the problem or find the probability of problem like this. So you can go down to the list and then find out the code in here, or you can follow along with me. So let's read the question here. So Terry Vogel, an amateur motorcycle racer, averages is 129.92 seconds per 2.5 mile lap in a second lap race with the standard deviation of 2.26 seconds, right? So we're gonna pause over here. We're gonna put the value in here. So the average, that means the mean, right? So that will equal to 1.29.92. Yeah. And then the standard deviation over here, that will have equal to 2.26. Yes. Okay. These numbers here, these are like, they describe the information, but this one, we not use these for the calculation, but these two. So that's exactly what we put in right here. That the mean, that would be 1.29.92, and then over here will be 2.26, right? So they want to say the distribution of her race time is normal distributed. So if it's not normal, then we cannot use this one here. So it's very important, this statement right here. Without it, we cannot use all this code right here. Okay. We are interested in one of her randomly selected laps, so just pick one. And then let X be the number of seconds for randomly selected laps. So we're going to have, this is what we have to find out here. So find the proportion of her laps that are completed between 1.29.18 and then 130.89 seconds. So that's what we're going to do here. We have the P norm. You're gonna do the probability of normal distribution, that's what is set here, right? And we're gonna take the upper one, that means 130.89, yeah. And then we can consider that mean and the standard deviation, yeah. And then we're gonna subtract the probability to have the lower one, so that's what we have the middle part, okay? So we're gonna do P norm of 129.18. And then I have the mean again, and then standard deviation. Yeah. So I'm gonna calculate it here. So I will have the answer in this one I have right here. So I'm gonna copy this one right here. So I put this right here. So that's the probability that her lap would be between some those two numbers. So roughly like 130 seconds per lap. That's what she did. Okay. Lap up 2.5 mile right here. Okay. Now the next one is say the fastest 4%. So remember, when we say fastest, that means less time, right? So therefore we're going to take the lowest 4%, right? We want to find out what time that would be. So therefore in this case here, we're going to use the Q norm. That means the inverse of the P norm, right? So Q norm, and then we're going to put that the probability in there, that means 0.04, yeah. And then we're going to use the mean again, standard deviation. So this will give us the time that could be the 4% of the fastest time that she has. Yeah, so do you have in here? So that would be the time right here. So around like 4% fastest, that would be 125 seconds that you have in here. Right, so I'm going to put in here. Yeah. And then now this one here is something like different. So let me draw the things for you to see in here. So I have this one right here. So I have my my thing right here, right? So I have the normal distribution go like this here, right? Try my drawing kind of messy right here. Okay, normal distribution right here. Okay, like that. So here is the mean right here, the mean right here, right? And we want the 40%, the middle 40%, right? The middle 60%. So that means you have right here. So middle 60% right here. Yes. So this part right here, 60%, huh? 60% right here, right? So we have right here 60%, yeah. So therefore, how much left here? So that would be 40% left, right? But to tell, so that means we will find the left, we will find right here, we find the value over here that we have 20% right here, right? 20% right here, right? And then we'll find the upper 20%. Or you can say, oh, I can do all of this here together. That make it, this one will be 80% right here, right? Make sense? Yeah. So that's what you're gonna find out. You're gonna use the P norm, but here you're gonna find out the um, the lower 20%, right? You're gonna Q norm, and then you're gonna do here the lower of 20%. That means 0.2, yeah. And then you have the mean. That's where you will have the lower value. So that's will give you the lower value right here. Right? So this one will be about like 128 second. That it will be the lower 20%. And then on this side right here, that we're gonna do the lower 80%, which we have right here. We're gonna find the value right here that we have in there. So we're gonna do over here, we're gonna do Q norm of 0.8, and then you have the mean, and then the standard deviation. Yeah. So that will give you the answer for the upper part, the upper number, right? So right here, so you're gonna have this number. I'm gonna put it right here. It kind of overlap over there. Yeah. So when you do like this, you will see so the mean is around here 129, and this is 128 to 130, 131. So she's really fast. You see, it's very dense. So this will be the middle 60% of her laps. Yeah, so it's gonna be fall in D2 time that you have in here, right? I submit. I should have all the correct answer right here. Yeah. So if you have anything you want to practice like this, go to the question below, get the question and practice again. Watch the video again if you need it. Okay, I hope it helped.